Hey Honors Pre-Calc, we are back. We're going over section 3, which is rates of change in linear and quadratic functions. Keep in mind, linear functions always have a variable with x to the first, and quadratic functions always have x squared. So let's go ahead and jump into it. So quick little review, average rate of change, aka slope, but specifically we're talking about a secant line. So a secant line is a line where there are 2 points on a graph. So let's say you've got 2 points on the interval A and B. So let's call this A right here, and let's call this B. Okay, if I sketch this up, this point right here goes over. This value of y is the function of f of A. And I follow this up here. This value here on the y-axis is also the value of f of B, whatever that is. So these points are called A comma f of A. And this point here is called B comma f of B. So this is kind of a review of what we've been talking about. But the change, if I draw this line, this is literally called the secant line because the secant touches the graph twice. So if I wanted to find the average rate of change for the secant line, I'm looking for its slope. So again, to find its slope, we would find the change of the independent, so B minus A. And in the numerator, we would have the change of the independent, so f of B and f of A. Subtract them, find the slope, and you've got your average rate of change. So let's go ahead and look at what does this look like here. So if we're talking about the average rate of change for the linear function, so this is y equals 2/3 x. Let's pick 2 points, right? I like clicky points, which means they cross along the grid. If I look here, I know the rate of change for my y value, where my dependent is we're going up 2, and my independent value is we're adding 3. So for my interval from 0 to 3, my average rate of change is 2/3. Okay, if I were to do that again and looked at, I don't know, this interval from here to here, we would see this. And then from the interval from 3 to 6, my dependent variable goes up by 2, and my independent goes up by 3. So again, my average rate of change would also be 2/3. Interesting. If I look at this one here, let's look for some clicky points. So I like these 2 points. Actually, these two are pretty good, okay? So if I know I go from -2 to -1, so my interval's from -2 to -1, my rate of change for the dependent actually goes down by 2, and my independent is 1, which is just -2. And if I do another one from, let's say, here to here, my interval from 0 to 1, so here's 0, here's 1, goes also down 2 in the dependent direction and 1 in the independent direction. Interesting that they both also have the average rate of change is the same. Go ahead and push pause right now. Try this one. Look at number 3, see what you think its average rate of change is. All right, let's try it. So along this line, let's say I chose from here to here. I know this interval is from -4 to -2. My average rate of change dependent-wise or vertically is 0, while my x was changing by 2. So that's an average rate of change of 0. I can also choose this as well, where my interval is from 1 to 3. So that dependent change is 0, and that independent change is 2 also here. So what do we notice about the average rate of change for both of those specifically linear functions? So the average rate of change for a linear function, if I look at here, it was 2/3 here, -2 here, and 0 here. These are all values that are constant. Okay, so as we look for a rate of change of any linear function, the rate of change for that linear function is always going to be constant. It's meaning that as the linear function is changing, the rate of change is not changing. Okay, So if I look at this here, so let's look at these numbers are kind of similar to 1, 2, and 3, right? These are the same exact functions. So if I look at number 4, it says find the rate of change of the average rate of change. So let's find the average rate of changes first, okay? So like for these two intervals, I already found them. I said the first interval from 0 to 3 was 2/3. And the second interval from 3 to 6 was 2/3. Well, what's the rate of change between 2/3 and 2/3? That's 0. So this is the average rate of change for the linear function, and this is the rate of change for the average rate of change. The rate of change for the average rate of change didn't change. It's a 0. Okay, let's look at the next one. If I look at the average rate of change for this, so notice how this is the same equation as this one up here. Okay, so if I look at my first interval, I said, okay, from -2 to -1, the average rate of change was -2. From 0 to 1, it was also -2. So what's the change between those two? It's also 0. Okay, if I look at this one up here, it's the same as this one. From -4 to 2, the average rate of change was 0. From 1 to 3, the average rate of change is 0. The rate of change between those two average rates of change is also 0. Okay, so here's what we know. This is kind of like a more deep understanding of rate of change, that the rate of change of the average rate of change of a linear function is always 0, meaning, again, the average rate of change is constant, meaning it does not change. It itself doesn't change. The function is changing, but the average rate of change is not changing. All right, let's look at this next part. It says find the average rates of change for, now we're talking about quadratic functions. So go ahead and highlight that. So we're looking for the average rate of change for quadratics, okay? And if your paper cut off like mine did, we're going to fill this in. This is x squared minus 2x on the given interval. So on each of these 7, 8, and 9, it's the same function. It's y equals x squared minus 2x for each of these, okay? So for the first one, number 7, the interval is from 1 to 2. And if I wanted to find the average rate of change, so let's look for this. So here's where x is 1, here's where x is 2, here's this point here, and then here's this point here, right? So the average rate of change here goes up 1 over 1, so that's 1 over 1, which is just 1. Okay, let's go to the next one. This interval is from 2 to 3. So from 2 is this point, and here's 3, it goes up right here, okay? So from the interval 2, 3, here's my rate of change. I'm going up 3 over 1. My rate of change is 3 over 1, which is 3. And for number 9, my interval here goes from 3 to 4. Here's 3, here's 4. If I follow these up, here's my points. And I want to know what is the rate of change. So here we went up 1, 2, 3, 4, 5. And over 1. So my rate of change is 5 over 1, which is just 5. Okay, so again, we're still using the same quadratic function. So let's look at 4 and 5. How would we find the average rate of change from the interval from 4 to 5 on the function? Remember, it's y equals x squared minus 2x. Well, in order to find this without the graph, we have to evaluate them on the points of this interval. So let's find y of 4 and y of 5. Okay, let's do input 4, input 5. So we have x squared minus 2x, x squared minus 2x. So here 4 is going to go here, and here 5 is going to go here. So if I input them, 4 squared is 16 minus 2 times 4 is 8. That's a total of 8. And if I plug in 5, 5 squared is 25 minus 2 times 5 is 10, which is 15. Okay. So if I were to plot these points would be 4, 8, and 5, 15, right? Well, if I wanted to find the average rate of change of these points now, okay, let's find or the function at 5 is 15 minus the function of 4 is 8. All over the difference of 5 minus 4. So we get 7 over 1, which is just 7. That's my average rate of change here. Last one, try number 11 on your own. I want you to evaluate the interval from 5 to 6 of our function x squared minus 2x. Go ahead and push pause. And we're back. Let's check to see what you did. So looking at our interval from 5 to 6, let's look and evaluate y of 5 and y of 6. So again, x squared minus 2x for both. And now we're inputting 5 here and then 6 here. If I evaluate that, 5 squared minus 2 times 5, we actually found it on the previous one, that y of 5 is 15. 6 squared is 36 minus 2 times 6 is 12, so that's 24. So to find the average rate of change here, we're going to take 24 minus 15, and the difference of the inputs is 6 minus 5. So that's a total of 9 over 1, which is just 9. So let's look at this, because we know all of those practice problems for 7, 8, 9, 10, 11 were all based on the same function. So let's look at the numbers of the rate of change for each of these intervals. Notice that the intervals here are going up by 1. So here's 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. So we're not jumping intervals. Every interval that we're evaluating it at is an interval of a value of 1 horizontal change or 1 independent change, okay? So let's look at these values. I'm going to put these values over here on the left side column, okay? So here we've got 1, 3, 5, 7, and 9. So we see on every interval that we looked at from 1 to 2, 3 to 4, 5 to 6, 7 to 8, or sorry, from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6, they all have a different average rate of change. So these are my average rates of change in between each interval. But let's look at now, what was the change between these intervals? So from 1 to 3, the change was positive 2. From 3 to 5, the change went up 2. From 5 to 7, the change went up 2. From 7 to 9, it was up 2. So what do we notice about the rate of change of the average rate of change? We notice it's positive 2. It is changing for the quadratic function. Before, for the linear one, it wasn't changing. But for the quadratic, the rate of change of the average rate of change is changing every time. So what do we say? Well, we say that the rate of change of the average rates of change for the quadratic function is constant, meaning it is changing. And in this case, this constant is 2. Okay. What if I asked you to find, find the rate of change of the average rate of change for 12 and 13. How would we do that? So let's find first, give yourself some values. Let's look at f of negative 2, f of negative 1, f of 0, f of 1. Okay, if I plug those in and evaluate them, here's negative 2x squared plus 10. We're going to plug this into each of those inputs, can go into the function. Okay, so here's negative 2, here's negative 1, here's 0, and here's 1. So if I get this, negative 2 squared is 4 times negative 2 is negative 8 plus 10 is 2. Go ahead and evaluate the rest of these. We get 8, 10, and 8. So these are the values, or the y values. So let's now look for the average rate of change, okay? So the average rate of change from 2 to 8 went down 6. The average rate of this from 8 to 10 was positive 2. Oh, sorry, this was positive 6. This was positive 2. And from here to we went negative 2. So how do we find the rate of change of the average rate of change? So from 6 to 2, we went down 4. And from 2 to negative 2, it's also down negative 4. So what do we say about this? Well, here's what we know, that the rate of change of the average rate of change, or AKA the rate of change, is changing by negative 4. Okay. Go ahead, and I want you to try this one for number 13. We'll go ahead and evaluate this for f of 0, f of 1, f of 2, f of 3, and f of 4. Okay, go ahead and push pause and evaluate those functions first. All right, let's see what you got. So this one we would go 3, 0 squared minus 2 times 0, which is 0. 3 times 1 squared minus 2 times 1 is 1. 3 times 2 squared minus 2 times 2 is 8. 3 times 3 squared minus 2 times 3 is 21. And 3 times 4 squared minus 2 times 4 is 40. Okay, so hopefully you got that first. Double check your answers with me. So first, let's find that average rate of change for each of these. So again, each of these intervals are 1 away, so I'm not worried about that difference of the independent value. So from 0 to 1, we added 1. From 1 to 8, we added 7. From 8 to 4, we subtracted 4. Wait a minute. This is 21, not a 4. So from 8 to 21, we added 13. And from 21 to 40, we added what is that? 19. Okay, so now let's look for that rate of change of the average rate of change. So how is this changing? It's adding 6, it's adding 6, it's adding 6. So what do we notice here? The rate of change is changing by 6. Or the rate of change of the average rate of change is 6. So what do we say about all of this idea? So let's put this main idea here. In a quadratic function, sorry, put it in purple. In a quadratic function, the rate of change is changing by a constant value. So that constant value is any number that it changes by, but it is a constant and it is changing. All right, let's turn the page. We're almost done. For number 14, it says the values of the function g are given by selected x values in the table. The function's either concave up or concave down, but not both. So how do we know what is happening here? So let's look at our x values. So I know our x values are all increasing by 1. So I notice that these intervals for x are increasing by 1 every time, which is really helpful because I know it's a consistent change in x. So let's look at the changes in the g of x values, or the dependent function. So from 18 to 20, I added 2. From 20 to 20, I added nothing. From 20 to 18, we subtracted 2. And from 18 to 14, we subtracted 4. Okay, so we see that the rate of change is the average rate of, or the rate of change is changing, right? If I were to sketch this, let's kind of draw this out really quick. So let's call, if this was like, I don't know, 15 was the value of x, here's, let's say 19, 16, 17, 18. And then let's say this value was 14, just to kind of see what's happening visually here. If I were to sketch this out, 15 comma, here's one more. So this would be like 15 comma 18, 16 comma 20, 17 comma 20, 18 comma 18, and then 19 comma 14. Okay, this is kind of what we're looking at here, something like this. Okay, so they asked us, what is it, up, concave up or concave down? We know, we're pretty sure that this looks like concave down, but how do I know this? So here's how we know. These numbers here, okay, 2, 0, -2, -4. If I look at the rate of change of the average rate of change is from 2 to 0 was -2, from 0 to -2 was -2, and from -2 to -4 is also -2. This has a constant rate of change, which is negative. And so because it's decreasing or it's going down, it's going to be concave down. So how do we say that? We say if the average rate of change is changing or decreasing, changing by negative, we know this is concave down. Vice versa, if the average rate of change is increasing or changing positively, we know this would be concave up. All right, y'all. I hope you have a great weekend. I'll see you back at class.